In that case, it's going to lose the heat energy. It's going to lose it. And for it to be lost, this cold one will have to absorb that particular heat. So in that case, we can say that all right, lovers of physics, let's do this again. We have this question that says 200 grams of water at 90 Celsius. It's mixed with 100 grams of water at 30 Celsius. What is the final temperature of the mixture? All right, we have some cold water here, which is 100 grams, and the temperature is 30. It's obviously cold. It's cold. And we have some water here, 200 grams at 90, almost boiling point, as you can see, almost at boiling point. It's hot. So we're going to find out the final temperature of the mixture when both are poured together. All right, this is very simple. What we do know is that the hot water, when being poured to cold water, the hot water has a higher energy, a higher heat energy based on the temperature it is at. So in that case, it's going to lose the heat energy. It's going to lose it. And for it to be lost, this cold one will have to absorb that particular heat. So in that case, we can say that the heat loss by hot water is equals to heat gain by the cold water. But this is only true under assumption that there is no heat loss during the case of the pouring. But of course, in actual sense, this is not always true, because as we pour in the liquid into this, there are some part of the heat being lost to the surrounding by the virtue of what we call convection. But that is another topic. So as the water is being poured, some part of the heat is lost. So this is only true if we assume that there is no heat loss to the surrounding or by any means. Remember, there could be also heat loss by conduction by the virtue of the container carrying the hot water. So some heat may be lost. So by this, we are assuming that there is no heat loss to the surrounding. Now, heat loss or heat gain is usually calculated by multiplying the mass of the substance by what we call the specific heat capacity of that body, then times the change in temperature. Now, for the heat loss, the hot water is at 90 degrees Celsius, while the cold one is at 30 degrees Celsius. Obviously, the final temperature must be something between 30 and 90 Celsius. In that case, we cannot get any value below 30 and we cannot get any value that is above 90. So the value we must have must fall within from between 30 and 90, because the cold body we have to rise in temperature from 30 to what we call the theta final, theta F. While the hot body will lose temperature from 90 down to a lower temperature, which we also called theta final, and by this they assume what we call thermal equilibrium. All right, now in doing this, let's find out the amount of heat loss by the hot water. This is given by the mass of the hot water times the specific capacity of the hot water, which is C hot, times the change in temperature. Now remember that the temperature of the hot water will fall from theta hot, temperature of the hot water, it will now fall down to final temperature which we are looking for. So, and heat gain by the cold water will be given by the mass of the cold water times specific capacity of the cold water times, now the cold water will have to rise from 30 up to theta final. In that case, theta final will be more than the temperature of the cold body, that is theta final minus temperature of the cold water. After this, we can now substitute. Now the mass of the hot water is 200 grams. Remember, there is no point trying to convert this to kilogram because they will eventually cancel out. There's no point converting to kg, which is the SI unit. You can solve with grams and we are good to go. Now, the mass of the hot water is 200 grams. So 200 times. Now, remember that the C for hot here is certain as the C for cold because both of them are the same substance. Water is water. So in that case, we can cancel this against this by dividing since they are equal, since they are the same substance. So multiply by temperature of the hot water was 90 degrees Celsius. And it's now reduced or fell down to final temperature theta F. While on the other hand, sorry, not this, is this against this place. So while on the other hand, the mass of the cold water was 100 degrees Celsius, 100 degrees Celsius times. Now, the final temperature is unknown. So it's going to rise from this to this. So theta final still remains unknown, minus the temperature of the cold water, which is 30 degrees Celsius. After doing this, we can go on to simplify this and solve for theta final. We have 100 here, 200, so we can divide through by 100, divided by 100, divided by 100. 100 we cancel 100, 100 cancel 200 to have 2. So we're having that 2 into 90 minus theta final is equals to theta final minus 30. Next we do now is to open brackets and collect like terms. 2 times 90 is 180 minus 2 times theta f is 2 theta f equals to theta final minus 30. To collect like terms now, we can bring this to this side or bring this to this side or vice versa. So let's do it this way. This is 180 here. 30 crossing is minus, it becomes plus 30 equals to theta final. This is negative 2 theta f. If crossing to the other side, it becomes positive theta 2 theta f. This plus will give us 210. And this will give us 3 theta final. If we divide both sides by 3, 3 we divide 3 to have 1. 3 in 21 is 7. 3 in 0 is 0. Therefore, the final temperature of the mixture is going to be what? 70 degrees Celsius. As you can now see, it is something between 30 and 90. That is the final temperature of the body. That is, the hot body will lose temperature from 90 to 70, while the cold one will rise, absorb the heat, and take temperature up to 70. Please, if you are watching this video and you have not subscribed to our channel or followed us on Facebook, please do that now. And if you're a lover of science, in fact, science is for everybody. We'll always be uploading videos of interesting topics in physics that affects our daily life. So if you're a lover of physics, do check back all the time to our channel. You will surely find some videos which require your interest. So see you in the next video. Bye bye.